Good morning, friends. Today we are looking at numerical number 2, wherein there is a body of mass 500 Newton traveling with a velocity of 75 meter per second, having air resistance or drag of 0.004 V square Newton, and they have asked us to calculate displacement of that same body when the speed reduces from 75 to 35 meter per second. Herein, there is one thing to observe, and that is the unit of R. It is an empirical formula where they have clearly mentioned that the unit is Newton, even though you are multiplying with V square. Okay. Next, for this particular example, we need some basics in a different way. That is, we know acceleration is dv upon dt, velocity is ds upon dt. Therefore, from this we can derive dt is equal to ds upon velocity. Great. Now substitute this in equation number 1, from which we can derive acceleration is equal to v into dv upon ds. Now this is what we are going to use to solve our example. Now coming back to example, draw its FPD. Of course, it is traveling in x direction towards right hand side, assuming. So the inertia force is going to act in opposite direction, ma, and resistance is of obviously in opposite direction, r. Now, using D'Alembert's principle, what it says is summing up the horizontal forces. Therefore, ma plus r is equal to 0. Accordingly, if we substitute ma plus 0.004 v square is equal to 0, then we have to substitute equation in form of velocity. So m is equal to v into dv upon ds plus 0.004 v square. If you substitute, and another thing to notice is the mass given here is in Newton. We have to convert it in kg because we are considering force and not the weight. So remember to convert the Newton into kg. So 5000 divided by 9.81 v into dv upon ds, as we have divided earlier. Same way substituted. From that we get an equation, that is dv upon v is equal to minus 7.848 into 10 raised to minus 6 ds. You can check this answer. Now from this we have to integrate it to get an empirical equation, and this is what our equation looks like. It is, now as we know it, integration of dv upon v is log v, but remember it is natural log, therefore I have written it as ln. So in calculator use ln and not log. Okay, so ln v minus 7.84 into 10 raised to minus 6 s displacement plus c1. Using boundary condition, we are supposed to calculate c1. So at s is equal to 0, velocity is 75. Therefore, c1 is equal to ln 75. So final equation what we get is ln v is equal to minus 7.848 into 10 raised to minus 6 s plus ln 75. Now this equation is for velocity when it is 75 meter per second. Now when the velocity reduces to 35 meter per second, just substitute v as 35 and get value of s. So accordingly, if you substitute v as 35, this is what you get. This is the equation we got, and this is the displacement, that is 97,112.64 meter. Thank you.